Welcome back. Today we're going to go over Unit 10 Quiz 2, and this covers quadratic and other nonlinear systems of equations. We're going to look at not only quadratic systems of equations, but also systems of equations with circles uh, and absolute value for a couple of these. We're also going to look at transformations of functions again with polynomial functions and absolute value functions, um, where we have to do a bit more manipulation with algebra for those. And then finally, we're going to look at solving systems of equations word problems. And this is where we have to figure out where x and y is, or what x and y is, to determine the meaning behind the problem that we're looking at. To start with here, we're going to look at this quadratic system. This is a nonlinear system of equations, and I've already plotted the first intersection point for us here. If we look at the graph, you can see very clearly that there's a point 0, -1. That's one of our solutions. You could go back and check that solution too. You could plug in 0 for x and -1 for y, and you should get a true statement when you do that. So we would get 1 equals 1 for 0, -1. Now for the second part, if we set both of these equal to y, we set this one's already set equal to y. If we set the second one equal to y, then we can set the two equations equal to each other. So if we plus y on both sides, we have y plus 1, and we get y equals 3x minus 1. Now we're going to substitute all of this y for that y there. And we have 3x minus 1 equals 4x squared minus 1. And we're going to set this equal to 0 so that we can determine what our x values are. We know one of our x values is 0, but we still have to find the other one. So we have -1 equals 4x squared minus 3x minus 1. We're going to add 1 to both sides, and we get 4x squared minus 3x, and that's equal to 0. So now we're going to factor this. And when we factor this, we take out an x, and we're left with 4x minus 3. So far we know x equals 0 from this x here, and that 4x minus 3 equals 0. We're going to solve this one for x. Divide by 4 on both sides, we get x is 3/4. So that's our x value for this first x value, or the second x value is 3/4. Then we're just going to plug in 3/4 for what y is for either this first equation or this second equation to get what y is. We're going to use the second equation. That's a little bit easier of an equation. We don't have anything to square there, so it's a little bit easier to solve, I think. So we'll do that. That's 9/4 minus y equals 1. And if we add y to both sides, we get 9/4 equals y plus 1. We're going to minus 1 on both sides. And 1 is the same thing as 4/4 if we're changing that to a fraction. So we're going to subtract 4/4. And we get 5/4 is equal to y. So 5/4 is our second value. All right, so the key takeaway, just make sure that you have both equations set equal to y. That way you can set them both equal to each other. And this should be a review for systems of equations in general. Let's look at the next one, though. This next one is interesting because we have an equation of a circle. So our first system, this is a linear equation, x plus y equals 2. But let's talk about what the next equation of a circle is. Let's actually set this one equal to y. So that's going to be y equals -x plus 2. And that's this blue line right here. We're going down 1/1. down 1 over 1 and starting at 2. Now the equation of a circle, that equation is x minus h quantity squared plus y minus k quantity squared is equal to r squared, where the center is hk and the radius is r. And this tells us r squared, but the radius is r, so we would find the square root of whatever r squared is. Okay, so for this is x squared plus y squared equals 4 is our equation of our circle, which basically says this: x minus 0 squared plus y minus 0 squared equals 4. And so we know that h is equal to 0 and k is equal to 0. So our center is at 0, 0. That's the center of our circle. We can actually just plot a point there for the center if we want to. Now our circle isn't actually land on the center. That's just for us to visualize where the center is located. So r squared equals 4. We take the square root of that, we get r equals 2. So now we know the radius of our circle is 2. We can go out 2 units from the center. This dot's already plotted, and we can just go out 2 units from the center. I like to just put 4 points like that because it's easy to go find the radius if you're going up or down or left or right. And then we'll plot the rest of the circle. I'm just doing a rough sketch though. Okay, so it says we want to find the intersection points of this. And it actually gives us multiple choice for this. It says select all the intersection points. At 2, 2 is right here, and that's not an intersection point. 1, 1 is there, that's not it. 0, 2 is an intersection point, and 2, 0 is an intersection point. So those are our answers for the system of equations with a circle and a linear function. All right, let's take a look at one more of these. This one doesn't give us a graph. It just tells us that one of the answers is negative 2, 2. And for this one, we already know what y is. Instead of setting it all equal to y, I mean, I suppose we could, but let's try a different method for this one. So if we plug in all of this, this is what y is. If we plug that in there, we can figure out what x is. Now you might be thinking, or you may have thought from the earlier problems that you could plug in, well, this is x and that's y. If you plug either of those in, you're just going to get one or the other again. So we have to find the other intersection point for this. So we have x minus, and I'm going to put brackets there, and then we're going to put all of what this y is for that y. And this is going to be 5x plus 1 quantity squared minus 3 is equal to negative 4. Okay, now we're going to distribute this negative, and we get x minus 5 times quantity x plus 1 squared, and then this becomes plus 3 is equal to negative 4. We're going to subtract that 3 on both sides. And I'm just showing you this way instead of solving it for y for equation 1. We're just plugging in this way just to look at an alternative method. So now this becomes that. And I like to write out the x plus 1 quantity squared. It helps me to write it out like x plus 1 times x plus 1. That helps me when I'm doing the distributive property. If you know the rule, that's great. For the shortcut method, that's great. I just like to write it out still, so that just helps me with these. So we get x squared plus x 1 is equal to negative 7. X squared plus 2x plus 1 is equal to negative 7. Okay, now we're going to distribute the 5. So we get x minus 5x squared minus 10x minus 5 is equal to negative 7. Okay, now we have this x and this minus 10x. We can combine these two here. And so we have negative 5x squared minus 9x minus 5 equals negative 7. I'm going to add 7 to both sides to set it equal to 0. And we have plus 2 is equal to 0. All right. Let's try to factor this with the AC method before we do the quadratic formula. Let's see if we get a good answer for this. So if we do A times C, we get negative 10. And it looks like if we did negative 10 times 1, that would add up to negative 9, or the value of B. So now we have negative 5x squared minus 10x plus 1x plus 2 is equal to 0. And we're going to factor by grouping. This should be review. We're going to take out a 5x, and we have x plus 2. That x plus 2 goes there, and we're just going to put a 1 there. It's times 1. Okay, now we have this factored. We're going to set each of the factor pairs equal to 0 to get our answers for x. And then we divide by negative 5. Negative divided by negative is a positive. So we get x is 1/5. And then this other one's really easy. It's just x plus 2 is 0, and we get x equals negative 2. All right, so now we're going to substitute in 1/5 for either of these because we already know x is negative 2. It told us up there. We want to find the other intersection point. So we're going to plug in x is 1/5. And let's do that for equation 1 because it's much, much simpler for equation 1. So we'll say 1/5 minus y equals negative 4. Okay, so now we're going to add y. You get 1/5 equals y minus 4, and a plus 4 and plus 4. And we get 1/5 plus 4 equals y. And we want to change that to fifths. 1/5 plus 20/5 equals y. And 21/5 is equal to y. All right, so our final answer for where these intersect is x is 1/5, y is 21/5. Make sure you write these answers in fraction form when you're doing these because this particular problem says the answer must be exact, so we just leave it as a fraction. All right, so now we're going to look at solving equations graphically. This shows us a polynomial function. So this is the graph of the polynomial. And then it wants us to just use the graph to estimate where, let's see, it wants us to estimate where x is to the nearest integer. So it says find an approximate solution to this new equation here. So for this one, we want to figure out what's going to happen with this new equation. This isn't technically a parent function, but this is our starting function. We could maybe call that f of x. And this is our new function, which we can maybe just call g of x. So the only difference here is that f of x, that's equal to 0, and this one is equal to 2. So if we minus 2 on both sides, now our function is shifting down 2 units. because we just have a -2 as our as our constant term. All the coefficients, all the variables are the same otherwise. So this is x cubed minus 2x squared minus 2x minus 2. That means this function is going to shift down 2 units. And to visualize that, you can take some different points that are on the graph and you can shift it down 2 units. That would be our new value. You can take this point here, shift it down 2 units. That would be our new value. And when we shift this whole function down, there's only going to be one x-intercept now because this part is going to shift down 2 units, and then all of this and that is going to shift down 2 units. So it's only going to cross on this portion of the graph. So if we look at the graph, we uh, can see that about here, if we went down 2 units, it would cross at x equals 3. And this is just getting us to visualize and round to the nearest whole number. So we're not being super accurate with this. We're just trying to estimate what's happening with the graph. Is it going up or down, and by how much? So this one is just x equals 3. That would be our approximate answer of our solution for what x is on the x-intercept for this. Let's take a look at another one. We have another polynomial graph, and it's graphed for us. This time we have multiple choice, trying to figure out how many solutions there are instead of estimating what the solution is. So this is our original function, f of x. We can call this one if we want to, and we can call this one g of x. Now when we add 2 to both sides, and set it equal to 0, all the rest is the same except for the constant term is now plus 2 on g of x. That means everything's going to shift up 2 units. Okay, so when we shift everything up 2 units, let's take a look what happens now. So if we had, let's see here, if we have this point, if we shift that up 2 units, it's going to go to there. If we have this point, it's going to go up to here. This point is going to go up to here. And let's see what else we can maybe estimate here. We could maybe say, actually, this point is going to go up 2 units. 1, 2, like that. Now the shape of the graph is the same because all of our coefficients on our variables are the same. So I'm going to do the best I can to sketch this as a similar looking graph. And I'm not a very good artist, so I'm just going to kind of do my best here with what it's going to look like. And actually, let's try one more point actually before we keep going. So this one, and we'll go up to like that. Okay, so now this comes around like that. So that's the best sketch that I can come up with for this shifting up 2 units. Now, if we look at the question, it says, how many solutions are there? Well, we just see one solution right there. And if we had to estimate, maybe it's about -1.25, but it's just asking us how many solutions there are. So in this case, there's just going to be one solution. So there's one x-intercept. All right, let's look at a couple more here. This next one is an absolute value equation. And again, we'll call this starting value or this starting equation f of x, and here's our new equation g of x. And And it wants us to find another approximate solution for given one of the solutions for our new graph of g of x. So remember, this is set equal to 0. And then if we do the same thing here and we subtract 3 on both sides, this is now 6 times absolute value x plus 4 minus 7. So what's happening to this graph is the vertex is, instead of being at -4, -4, so this was the original -4, -4, the vertex is now at -4, -7. So everything's scooted down 3 units. So it says when we shift this down 3 units, x equals -5 is one of our answers. So we haven't changed how wide this graph is. We haven't stretched it. We haven't made it thinner or wider. It's the same shape. It's just been shifted down 3 units. You can't really see it on the graph, but maybe the vertex would be about there. So it says x is -5 is one of our solutions. So that means that is about one of our solutions. Now you might be thinking, well, that's just 2 units from there to there. We are just doing approximations. So really we would say right there is x is -5. And so it's saying, well, what's the other one going to be with the other intersection point? There's 2 intersection points originally. And so our second one's just going to be there. So our original intersection points are here and here, and our new ones are those 2 black dots. So x equals -3 is our other intersection point. All right, let's look at one more. This one I think is good to examine because quadratic systems of equations, or excuse me, quadratic equations, it's important to just be a little more familiar with those. So again, we set this first equation equal to 0. This is the graph of it. It's showing that the vertex is one solution at x equals -2. And then if we add 2 to both sides, you're probably getting the pattern of this now. We're going to shift everything up 2 units. So our new vertex is going to be right here. And we can take some other points and we can shift those up 2 units also. So we can go from there and we can shift it up 1, 2. We can start from here. We can shift this up 1, 2 units. And then we can redraw our parabola. And again, our parabola hasn't changed in width. It's the same parabola. It's just shifted up 2 units. So now we want to figure out how many solutions that this has. Well, it's got 2 solutions. Okay. All right. The next part is using a graphing calculator. We're going to solve these graphically for these. And we need a graphing calculator for these because if we don't have a graphing calculator, we're not going to be able to find the answers with estimation. So go to desmos.com/calculator. I already have my calculator open. I'm just going to show you how to solve these next ones here. So let's see here. We'll just share the whole screen here. Okay, so we're going to write our equation. So our first equation that it gave us was the cube root of x equals x, absolute value of x minus 2 minus 1. And I'm going to show you what happens when you write it exactly the way that it gives you the equation, because you're going to find that you're going to get an error. So this is what it told us on Desmos. And then I'm writing absolute value. You can press shift / to do a up and down absolute value, but it's also right here. You can close the absolute value that way. And then -1. Now when you do that, you're just going to get a graph and it's not going to make any sense. It's going to get 2 lines and it's going to not show you what you need to find. Instead, if we set it equal to 0, that's the same thing as when y is equal to 0. And so we just write it as a y equals equation. So we're going to minus cube root of x on both sides. So we get negative, I'm just going to copy this, cube root of x plus absolute value of x minus 2 minus 1. Now we're going to get rid of this red graph. We don't need that at all because that wasn't even what we wanted to find. This is our graph. And it tells us on the original problem, it says one of the solutions is x is about equal to 0.3. Let's see if that's true. So here's one of our solutions, and it is 0.31767 is one of our solutions for x. And we want to find the other solution. Well, it tells us if we zoom in enough, you can see what it is. It'll tell you right there. But if you really need to zoom in more and be more accurate, you can find out what it is also that way. We want to find the nearest tenth. So I like to just go to the tenths and then see if it goes past um, uh, the 5 in the hundredths place or not. So this is 4.67. So the nearest tenth would be x is about equal to 4.7. So let's just write that on our answers here. X is about equal to 4.7. All right. For the next one, it's going to tell us, it tells us these two solutions. And it says that there is a third solution that we need to find. So again, we're going to put this equation in our calculator. I'm going to put it in just as a friendly reminder for everybody. The way that if you put it in the calculator this way, it's not going to give you a solution. Just to remind you that if you do it this way, it won't tell you the right graph. And then also make sure to zoom out so you can see everything again. In this case, that's what it would show us. So we're going to set it equal to 0. So a really easy thing to do is just do that. And then you can copy this and then say y equals, and we're going to minus all of this on both sides. So we have the negative of what we just copied. And then all of this stays the same. So we're just adding that to that side. We're getting rid of that graph. If you want to do it that way, you can, or you can solve it on paper and then figure out what this would be. Either way is fine. You're just going to get the same answer. Okay, now it tells us our original solutions. It says that the first one is negative 0.6, or roughly that. That would be that point there. The other solution it gives us is negative 1, and it wants us to find the third solution, which is negative 1.35. And again, it says to the nearest tenth. This is 0.35, so we're going to round up to negative 1.4. All right, so negative 1.4 is our answer for that one. All right, so that was just some Desmos, I suppose, review, and we're just going to do a couple of these ones for Desmos. So the last part of this is solving uh, word problems graphically. So for these word problems, we need to figure out what X represents and what Y represents. And then also if they're talking about um, if it represents 1, or if it represents 100, or if it represents 1,000 or 1,000,000. I think that's very important to determine what the units are. So this first example says an entomologist can model the number of mosquitoes in a forest as a function of rainfall. So they're saying that the amount of mosquitoes that are there changes depending on the amount of rainfall. And this blue function tells us the rainfall. and it's given in centimeters. I think this is supposed to say Y gives the number of mosquitoes in the forest in millions. I think that might be a small typo there. Actually, no, it says the function itself. Yeah, so it's implied that Y gives the number of mosquitoes in millions. So X is the rainfall, Y is the mosquitoes. And I like to write these down. That just helps me when I'm thinking about what the word problems mean. Okay, so it says Y equals 3 here. I'm thinking mosquitoes, it probably wouldn't make sense that there's 3 mosquitoes. And it says here the mosquitoes are in millions. So this means that at Y equals 3, there's 3 million mosquitoes. So we're going to interpret what these intersection points mean because it says which statements represent the meaning of these intersection points. So we have an intersection point there, and those are the solutions to our equation. So looking at this first intersection point, this says there's 3 million mosquitoes and about, maybe we could say about zero point 0.7 centimeters of rain. And this second solution says there's 3 million mosquitoes and maybe about 4.4 centimeters of rain. So it says, what are these statements telling us? So are these statements true? Are these not really making any sense? So choose all that apply. The first one says that these intersection points tell us the number of mosquitoes when the rainfall is 3 centimeters. Well, when the rainfall is 3 centimeters, that's right there. And there's no intersection point there. There's nothing that crosses there. It tells us when there's 3 million mosquitoes, but not 3 centimeters. So not A. This one says they give the solutions to the equation 5x squared equals 3. Well, our first equation is y equals 5x minus x squared. Excuse me, 5x minus x squared equals 3. Our first equation given to us is y equals 5x minus x squared. The f of x can just be changed for y. And then our next equation is y equals 3. So yes, we can plug in 3 for y, and we would get that equation, and that would be our 2 intersection points. So B is the correct answer. And it says choose all that apply. So let's look at the next ones here. It says that these 2 points describe the situation where the number of mosquitoes is equal to the rainfall. Well, that doesn't make any sense because the rainfall is about maybe zero point 0.7 and then 3 million mosquitoes. So that's not equal for that point. It's not equal for that point either. That's not correct. And then for D, it says these intersection points describe the amounts of rainfall that relate to 3 million mosquitoes. And that is true. This tells us that's how much rainfall there is when there's 3 million mosquitoes. And this one tells us that's how much rainfall there is when there's 3 million mosquitoes. Okay, let's look at another one with logs. I think sometimes students feel intimidated when they see logarithmic equations, but really the same rules are applying. It's just a different kind of equation. We use logarithms in medicine to show rates of decay in medicine. So when we take medicine, it slowly leaves our bloodstream, but it doesn't always leave at a steady pace. So sometimes we use logarithms to show that. So this is talking about a pharmaceutical scientist who's studying 2 medications And they're wondering how long the medicine stays in somebody's bloodstream. So we have our first function in blue, f of x is negative 1.25 times the natural log of 1 over x. So the blue one is that one. X is the initial amount of medicine in milligrams. So X is the initial medicine in milligrams. The corresponding function of the other medication, or g of x, is negative 1.8 times the natural log of 2.1 over x. And it gives us the graphs here. And we want to figure out the meaning of the intersection points on the graph. Excuse me, intersection point singular of the graph. So that's about there. All right, so it says, what does that intersection point tell us? It gives us the solution to the equation, is what A is asking. And it would be the solution. If we set this one equal to y, and that's also equal to y, we can set those two equations equal to each other, and then we can solve for what x is, and we will get their point of intersection for the x value. We plug that x value back in, and we get what y is. So yes, it gives us a solution to the equation. The next one says it means with an initial amount of about 11 milligrams for either medicine, there's going to be some of each medicine in the bloodstream for about 3 hours. Okay, so for this this one kind of was confusing to me when I first saw it. We're talking about a rough estimate of about 11 milligrams of medicine. So yes, there's about 11 milligrams on the blue there. And yes, there's about 11 milligrams on the the pink g of x graph. So that part's true. Now it just says that after 3 hours, so y is the time. I forgot to write that earlier. So y is the time, and this is the medicine amount. It says after 3 hours, there's going to be some of each medicine in the bloodstream. Well, in this case, there's more medicine as time is going on. And so, yes, after 3 hours goes by, this is at 3 hours, there is some medicine in the bloodstream. So B is a true statement, although it's not telling us a lot about what those values are. It's just saying some medicine's going to be there. All right, C says it gives the solution to the equation negative 1.25 times the natural log of 1 over x equals 0. That's not true. That would be just what f of x is. It's not necessarily the solution to it, though. And then for D, it says it means that there's always more of one medication in the bloodstream than the other. That's not necessarily true either. So it looks like for G of X, for the first 3 hours, there's slightly more medication in the bloodstream than F of X. And then after 3 hours goes by, um, it looks like we've got more medication in the bloodstream for f of x after 3 hours goes by. So not D. Um, and the key takeaway is it says always, there's always more of one medication than the other. And that's not true because here these two are the same exactly at that point. All right, let's look at a couple more of these. This next one's a little simpler. It tells us these two functions, f and g, can be modeled with heights of two airplanes. T is the number of minutes that have passed since noon at an airport. So airplanes, as they're flying, they're not always at the same altitude. And then, of course, they have to land as well. But when they're up in the air, sometimes they're changing altitude slightly. So it says the airplanes have the same height about 9 minutes after noon. So T is in minutes. So 9 minutes after noon is right there. It's just before the 10 on our graph there. And it says, what's the other time that the airplanes have the same height? Well, the other time that they have the same height is when the two functions intersect. And that's right there. And we just go down and check to see what that value is. And that's about 90 minutes after noon. That one was kind of an easy one. But that's just another way to examine what it means by an intersection of two graphs is it's just where they are the same. Okay, the last one, this is a good example for an investment type problem because we have to figure out what part are we talking about that relates to the time and what part is the money. So when we make an investment over time, we make extra money from the bank. And then as time goes by, we make extra money on the extra interest that the bank gives us. And that's why we use an exponential formula for this. So we have the balance of Jaylene's account, and we have the function for that account. And we're using E to show exponential growth in this case. And T is basically our X value, and T is the time. And it shows us the graph of F and the graph of Y equals 3000. So our X-axis is actually our T value, and that equals time. And Y is equal to the money. So this says which statement represents the intersection point of these graphs. Choose all that apply again. Before we even look at the multiple choice, let's zoom in on this and see where the intersection point is or get a rough idea and figure out what it means. So this would be 13. Let's make sure T is in years. Yes. This would be 13 years, about 13 years. Let's just call it 14. It's very close to 14 years. So we'll say at 14 years, there's about $3,000 in the account. And we can look here at 0 years. She started with 1,000. And if you know exponential equations really well, you'll notice that that 1,000 is right there for our starting value. But anyway, this is less about exponential equations and more about systems of equations. So let's look at all the answers that apply to this. For A, it says it describes a situation where the account balance is equal to the age of the account in years. So the account balance is 3,000 and the age of the account is 14 years. Those are definitely not equal. So it can't be A. For B, it says it gives a solution to the equation 1,000 times e to the 0.08 t is equal to 3,000. Here we have y equals that part of the function and y equals 3,000. And we're setting y equal to y, and that's our intersection point. So B is true. For C, it says it describes how much time it takes for the account's balance to reach $3,000. That's also true. It's at 3,000 when y equals 3,000. And then for D, it says it gives the account balance after 3,000 years. That's not true. The years stop, it looks like that's 26 years. There would be no way to know what 3,000 years is from the graph, but it would be much more than the 3,000. So this question is just making sure that we're not mixing up years and dollars. Okay. All right. So that is everything for this section on systems of nonlinear equations.